So now we can generalize this rule of splitting the region and finding area under the curve. So now moving from that simple shape, now suppose if we have this kind of a shape, suppose this is the point, okay, this is the curve like this. Now these are the points. We are going to generalize the whole process of splitting the region into slices. And now I have a curve, this curve, and this curve is coming from somewhere, going to somewhere, but I am only interested in this part of the curve. And I am interested to know this shaded region, the area of this region, that what is the area of this region. So we will apply the same procedure, that we can split this whole thing into slices, small slices, like this. And I say,
what
okay,
about that question you gave?
okay, let us finish this first and then we can discuss it.
Okay.
So we are going to generalize the whole process of splitting the region area to find the area under the curve. So this is a curve in the blue, and I am interested to find the area of this curve in the region AB. So my interval is AB. I'm only interested in this interval from this point to this point, this whole shaded region. So the same thing, because one side of the shape is not a straight line, so I cannot directly apply the rectangle formula. So I have to split this into small rectangles. Now I'm assuming that these small look like rectangles. So this is S1, this is S2, this is S3, so on, and the final one is Sn. So I have splitted the whole shape into n small slices like this. So you can see the first point of this slice, this is the starting point, and you already know that the starting point is always called x naught. So actually x naught is equal to a, the starting point. Then of course after the x naught, then this one is x1, this is x2, x3, and so on, and the final one, this point is xn, which is equal to b, the final point. So what I have actually done, I have splitted the big interval AB into small intervals. Small intervals like what? The first interval is this one, x0, x1. The first slice, x0, x1. Then x1, x2, x2, x3, and so on. After many intervals, x1 less than n into xn, and the xn, because whatever this point is, the very previous will be 1 less than this, so that is n minus 1. Now keep in mind that I am again considering the right endpoints for the first time. Now if I am considering the right endpoints, the rule which we were applying in the case of the parabola, y equals to x square and the interval was 0, 1, what was that? The rule was that the area of one slice will be this displacement delta x into the value of the function, if I am considering the right endpoint, the value of the function at the right endpoint of the slice. So what is the right endpoint of the slice? That is x1. So this was the rule when we were doing it for that. For example, when we were doing it for 0.25 as the delta x, and we said okay, this thing will be 1 by 4 square. So what is actually that? This 1 by 4 was x1 and the square was coming from the rule of the function. So it is actually y is equal to f of x. So we were actually applying the rule of the function on this point. So that's what I have written here. The rule of the function at this point, whatever the rule is, in this case it was x square, so it was becoming 1 by 4 square. If it is x cube, then it will become 1 by 4 cube. If it is the square root, it will become 1 by 4 square root, whatever the rule of the function is. So here the simple thing is in general that the rule of the function, the value of the function at that point into the smaller slice delta x. So this is the general rule. Now in this case, if you look at it, I have already told you that x naught is a. The first point, starting point, I have named it as a. Now what is x1? x1 is actually x naught, this point, plus this distance. So it is actually x naught plus this distance. When I add this distance into x naught, it becomes x1. So it is x naught plus delta x. Is it okay? Zephyr,
Yes, yes.
when I am standing at x naught and I want to reach to x1, so what I have to do? I already have this value. This is my value at the current position. Now if I add into this value, if I add this distance, which is delta x, then I will reach to this point. So that's what I'm writing
Okay.
here.
Yes, sir.
So this is this. Now similarly, if I want to go to x2, it means I have to add another delta x into this distance, x naught plus this delta x plus another delta x, x naught plus this delta x plus this delta x. When both added, I will reach to x2. So it becomes x naught plus 2 delta x. Right? Similarly, x3 will be x naught
Yeah.
plus 3 delta x, and so on. So these are the things which we are going to use in the general expression. Now, here I already told you the rule is this. So the rule says, this was just to explain to you how the slices will add up. How, if you want to figure out these you can always relate them with each other. You can always relate any position, ith position, with the initial position. So you can see every position is related with the initial position. So how many delta x are added? It will tell you the position of your position, present position. Anyways, so the rule is, this rule, it says that if you are considering the right end point, then wherever you are standing, let me say I am standing at any ith position. Suppose here, this is I, xi. Because we are generalizing this thing. But if I am standing at any ith position, which is in between n and 0, this position, then the rule says for this position, if I am using the right endpoints, the formula is delta x into the value of the function at that certain point xi, the right endpoint of ith slice. So whatever slice is, if it is 1, then it will be f of x1. If it is slice 2, then it will be delta x f of x2. But keep in mind the right endpoints. So if it is si, then the rule is delta x dot f of xi. So far it is okay. This is okay so far.
Yes, yes.
Okay. Now for total Rn, we said that the total area of the region approximated by the slices is the sum of all the slices, areas of the slices according to the right hand points. So the total Rn is delta x into f of x1 plus delta x into f of x2. This whole thing is written on the pages, you can read. Plus delta x into f of x3, so on up to the final point, delta x into f of xn. This is okay? This is the general rule. For the first slice, you will use this formula. What is this? It means the right end point of the first slice and the value of function for the at that point into this displacement plus
Yes.
the second slice plus the third slice and so on up to the nth slice. So this is the general rule. Now I'm going to write the definition. The definition says the area of a region S that lies under the given curve, under the graph of a continuous function, which is the curve y equals to f of x, whatever the function is the limit of the sum of approximate areas of the smaller rectangles. This whole thing is written on the page, you can read it. So according to this definition, if I want to write it mathematically, then area of any region, for example in this case the region was this, so this was my region, the area of this whole region in between A and B, the area A, it is equal to the limit n approaches to infinity Rn, that is the limit n approaches to infinity delta x dot f of x1 plus what was Rn? I just written the value of Rn before this. The Rn was delta x dot f of x1 plus delta x dot f of x2 plus so on delta x dot f of xn. This is the definition of area for the region under the curve if I am using the right end points. Similarly, if I am using the left end points, then what will be the change? The answer will be always they will be approximately near to each other, but the change will be, now the intervals were like x0 x1, x1 x2, x2 x3 and so on xn minus 1 to xn. This thing I calculated by using the right end points. If I want to write the same definition but using the left end points, the change will be, the area will be limit n approaches to infinity ln instead of rn, limit
Someone is trying to join.
limit n approaches to infinity limit n approaches to infinity. Now here will be something changed. The thing will change. Now I am considering these points, left end points. So the first slice will be delta x into the value of the function at x naught. You see the difference? The difference? What is the difference in between these two values?
X1.
Yes. In the case of right hand point, the area of the first slice is delta x into the value of the function at x1. Again, this is also the area of the first slice. These both are belong to the same area. Both are area of the S1. But when you are considering the right hand points, it is delta x into f of x1 for the right. And for the left, it is delta x f of x naught. Similarly, the area of the slice 2 will be delta x dot f of x1 plus so on. The area of the nth slice will be delta x dot f of xn minus 1. Number of terms are same. 1, 1, 2, 2, 3, 3, n. The point of difference, delta x is same. The point of difference is the value of the function is taken at x1 in case of right hand points. The value of the function is taken at x0 in case of left hand points. Similarly, for the slice 2, value of the function is taken at x2 for the right hand points. Value of the function is taken at x1 for the left hand points. This is the difference. So, for the left, I focus on these points. For the right, I focus on these points. That is the difference. But both will always give you the general answer will be equal from both ways. But if you are calculating for 4 intervals, 8 intervals, the values will be approaching from two ends to each other. One will be coming from the bigger, other will be coming from the lower. But if you will calculate the value in the form of n, the answer will always be same. For example, in the previous example, the answer from both sides was 1 by 3. So, in general, the answer will be same whether you take the left points or you take the right points. But in small number of pieces, the values will be coming from both sides. Now, there is one more thing which we can do to make the things more easy. And that thing is instead of focusing on the left point or the right point, the intervals are these. xn minus 1, xn. Instead of focusing on these points, if I say let's suppose x1 steric is a point which is a midpoint of these two numbers, that is x0 plus x1 divided by 2, then it means this is the point which is somewhere here in between them. Of course, this will give me a more better answer. Similarly, I can say x2 steric is a point which is in the middle of these two. So it is x1 plus x2 divided by 2. Similarly, xn steric is the point in the middle of these two. That is xn minus 1 plus xn divided by 2. In that case, area right limit n approaches to infinity, delta x into the value of the function at the middle point, x1 steric, plus delta x into the value of function at the middle point of the second interval, plus so on, delta x into the value of function at the middle point of nth interval. So this rule is called the midpoint approximation. So now we have three methods to approximate area under the curve: using the right endpoints, using the left endpoints, using the midpoints. All these three rules working with the same formula. If you are considering the midpoints, then first from the given points, you will have to calculate the midpoints for each interval. Here, you are only know the left endpoint and the right endpoint of this interval. So to know the middle point, whatever, for example, if this interval is 1 and 2, x0 is 1, x1 is 2. So you cannot apply midpoint rule directly on these 2 points because this is the left endpoint, this is the right endpoint. If you want to apply the midpoint rule, you have to calculate x1 static. That is 1 plus 2 divided by 2. That is 3 divided by 2. This is the point which is in between these two numbers. This is the midpoint. This value you will use here for the first slice. So the function value for the first slice will be calculated at this point according to the midpoint rule. Do you get it?
Yes.
Nice. Now let's do an example. And in general, you know, maybe you know or not, we want to write it more beautifully, this whole formula. So I can write them for you using the right hand points more beautifully. The formula is area equals to limit n goes to infinity summation I from 1 to n f of xi delta x. Do you know this thing? Do you know this?
It was 1.
Okay, let me tell you. Let me write it here. It is f of x1 delta x plus f of x2 delta x plus so on f of xn delta x. Do you know this? This is Rn. You know this?
Yes. Rn.
Now, this and this guy are same within the circle. When you have something in the form of sum from 1 to n, then you can say, okay, summation, this symbol shows the sum of some terms from 1 to n, summation starting from 1, reaching to n, f of xi, that you will place the I where the guy is changing. The rest of the things will not get the I. So you can see in this whole expression, the subscript of x is changing. x1, then 2, then 3, then 4, then n. None of other things are changing. So the other delta x is same, f is same, x instead of x1, 2, 3, you have written xi. And you said that summation I starting from 1 to n f of xi delta x is this. So when you will expand this, it simply means you will pick up one value of I from here, one by one. Your I is actually 1, 2, 3 up to n. You will pick up one by one each value, put it here, and you will get this. When you pick up 1, put it here, it is f of x1 delta x plus. Plus is coming because of this summation symbol. Plus, when you, now 1 is gone, the next value is 2. When you will pick up 2, put it here, it will become f of x2 delta x, it will come here. Plus is coming because of summation. Another plus because of summation. Now 1 is gone, 2 is gone, the next value is 3. You will put it here, it will become f of x3 delta x, f of x4 delta x, so on. The final value is n. So when you will pick up the final value, it will become f of xn delta x, which is here. After that, you don't have any value, so you will stop here. So this is the open form of sum of n terms, and this is the compact form of sum of n terms. Both are same. Okay?
Yeah, okay.
So in more beautiful form, using the left hand points, this is the formula for area. And similarly, in more beautiful form, using the left hand points, area is limit n goes to infinity. I is again starting from 1. No, I will start from 0 and it will reach to n minus 1. Yes, f of xi delta x. Now why it is starting from 0? Because you will, if I want to write it into the open form, it is like limit n goes to infinity, f of x naught. In case of left hand points, we started with x naught. In case of right hand point, we started with x1. So it is f of x naught delta x plus f of x1 delta x plus so on, f of, the final was f of xn minus 1 delta x. This was the final term. So you can see, when you pick up 0, it is f of x naught delta x. Plus coming because of summation. The 0 is gone, the next value is 1. Now your I is 0, 1, 2, so on up to n minus 1. Again, the total number of terms are n. Here additional term is 0, so it is 1 less than n. So if you count them, the total number will be n. This is 1, this is 2, this is 3. If you count these, do you know? This term is 1, this is 2, this is 3, so on, this is n. So actually again the digits are n, but actually they are starting from 0, that is why they are ending at 1 less than n. If you start from 1, they will end at n. If you start from 0, they will end at n minus 1, 1 less than n. So when you pick up 0, it becomes here. When 0 is gone, the next is 1, it is there. The final term is n minus 1, it is there. So this is the compact form of left hand rule, this is the compact form of right hand rule, and the third one, the compact form of middle point, is area equals to limit n goes to infinity summation I from 1 to n f of xi steric delta x. Now it is the same, it is limit n goes to infinity. When you open this I1, it will become f of x steric 1 delta x, plus for I2 it will become f of x2 steric delta x, plus so on, f of xn steric delta x. Right? So this is and this is same. You can write both ways, it is up to you, but this looks more beautiful. X equals to cos of x. Now this is the function. Now we are gone with the previous function was the parabola y equals to x square. Now y equals to cos of x. F of x and y, they are always the same. And you are asked to find area under the region for this function, and the region is that your starting value is 0 and the ending value is b. For the moment b is any number. And part 1 of the question is use right endpoints to find an expression of the limit. Expression in the form of limit for the area under this curve. So just like you did, why you guys quit and then join again? What's wrong?
I don't know. Why didn't
Stay here if you want to stay. If you want to go, just go. I don't, it's, for me, it's not a problem. Now, the total interval is this. And one thing, let me tell you, that if you simply want to calculate the delta x is always the final point minus the initial point divided by the number in which you are splitting the interval. So if you are splitting the interval in n numbers, then it is final point minus initial point divided by n. For example, in case of the very first example, the interval was 0, 1 and I splitted the whole region into 4. So I said that the delta x is the final point 1 minus the initial point divided by this guy in which you are trying to split the region. So it was 1 by 4, it was 0.25, right? This formula. So in general, this is the formula.
Yeah.
The final point minus the initial point divide by the number by which you are trying to split the region. Here in the first part, he asked me to find a general expression in terms of n. So it means I am trying to divide the interval into n number of regions. He has given me a is equal to 0. So I can replace this a with 0. So my delta x is b minus 0 divided by n. So this is my delta x. A is 0. Okay? This is okay?
Yes.
Okay, good. Now, x naught is 0. I need the points. I want to split this thing into I want to split, if this is AB, then I want to split this thing. The first point is x naught, which is, I'm saying it is x naught. The second one will be x1, then x1, x2, and so on up to xn minus 1 and xn. So I am asked to use the right hand points to find the expression. So I am interested to find these points because I have to use them. So for this point, I need x naught. I told you that x naught is the starting point. X1 means x naught plus 1 times delta x. Right? Look, this is okay? Do you remember?
Yes, yes.
Okay.
Yes.
Now x naught is 0 and delta x is b divided by n. So my x1 is 0 plus b divided by n. So it is b divided by n. So I got first right end point. Now I need to know x2. I told you x2 is x naught plus 2 times delta x. X naught is 0 and 2 times of delta x means b divided by n. So this is the value of x2. Similarly, x3 is x naught plus 3 times delta x. X naught is 0. 0 plus 3 times delta x is b divided by n. So it is 3b divided by n. It simply means that the final xn will be, if you look at the pattern, when there is x3, the multiplier is 3. So when there is xn, the multiplier will be n into b divided by n, right? You can see this pattern.
Okay.
Now look at the pattern. 2b divided by n, then 3b divided by n. So when it is x1, it is 1b divided by n. x2, 2b divided by n. x3, 3b divided. So it means wherever you will go, that number will come here and it is here. So I needed these points in the formula. That's why I have to calculate them first. Now I got these points. Now I can simply plug in into my formula. The formula was, in simple, it was f of x1. For the right hand points, you always start from 1. Delta x plus f of x2 delta x plus f of x3 delta x plus so on f of xn delta x. Now I have all these things. Rn equals to f of x1 means the value of the function at the point x1. x1 is b divided by n. The function is cos of x. So it means, okay, one more step we can go. F of x1 means the value of the function at the point x1. What is x1? It is b divided by n plus into delta x plus f of x2 means the value of the function at the point x2, which is 2b divided by n, plus so on. F of xn means the value of the function at the point xn, which is nb divided by n into delta x. Sometimes we do not simplify the things here because they can help us later on. You can cancel these two n's, but I don't want to cancel them. So now what does this mean? This means the value of the function at this point. What is function? Function is cos x. So I can plug in this function here. Instead of f, I will write cos of, and instead of x, I will use this value. So cos of b divided by n into what is delta x? It is b divided by n. So in the multiplier, we have 1b divided by n plus value of the function at this point. What is the function? Cos. What is the value? 2b divided by n into, here we have delta x. What is delta x? It is b divided by n plus so on. Then what is function? Cos. What is x? nb divided by n into what is delta x? b divided by n. This expression we got. Now I know that area is equal to limit n approaches to infinity Rn, and I have calculated Rn over there, so I can replace this Rn with this value. So it is limit n approaches to infinity. What is Rn? Rn is this guy, and in this guy, one thing is coming common, so you can pick it up outside. So b over n is outside as a common. Now inside I have cos of b over n plus cos of 2b over n plus so on, and the final term is cos of nb over n. Up till here you are done, because he only wanted you to give an expression of the area in the form of n and in the form of limit. So if you can simplify further, that is a plus point. If you don't want to do, here you are done. This expression is fine. This is the answer for the first part. The function is f of x equals to cos of x, and the interval is 0b. Now this time, initially he didn't give me any value for b. Now in the part 2, he is giving me a value for b. He said that this b is in between 0 and pi by 2, because this is a cos function, so of course the values will be in the form of angle. And he further gave me another data. Now this information is given. Another data is that use n equals to 4 means split the whole region of this function into 4 slices. N equals to 4. N is always, n means the number of slices. Keep this thing in mind. If n equals to 100, it means you have to split the region into 100 slices. If n equals to 4, it means you have to split the region into 4 slices. Now, again, the question is, what is the question? Take n equals to 4 and b equals to, okay, he gave the fixed value, b equals to pi by 2. B equals to pi by 2 and a is same 0. estimate the area using midpoints. So key point is midpoints. So we are not dealing with left hand points, we are not dealing with right hand point, we are dealing with midpoints. So to calculate the midpoints, first I need the left and right points. Then from there I will get the midpoints. Anyways, now, so to calculate the points for this interval, first thing is you need how much will be the width of the slices. The whole slices you are going to make, then how much will be this width? That is delta x, and you know the formula for delta x, it is b minus a divided by n. In this case, b is pi by 2, a is 0, divided by n is what? 4. So the slice will have the width delta x equals to pi by 8. So keep this thing here. The size of the delta x is pi by 8. Means I have to make slices of this width. That is the value of delta x. I got it from this formula which I told you. Now, from this width, now I can make the slices. Then how you can make the slices? You actually have to split the interval. Now your interval is this. So it means it is not 0 to b. It is now 0 to pi by 2. And you have to split this whole interval into this size 4 times. So this size means the first interval will be 0 and pi by 8. The second interval will be pi by 8 and pi by 4. The third interval will be pi by 4 and 3 pi by 8. Yes. And the fourth interval will be 3 pi by 8 and the final guy pi by 2. So you have made 4 slices using the value of n4 and using this width. You have splitted the region into this. Now you have the left hand points and the right hand points. But no, still the data is not enough because he asked me to solve using the midpoints. So from there I have to calculate the midpoints. So the first midpoint will be x1 static, and that is what? X1 static is the middle point of these first slice, means 0 plus pi by 8 divided by 2. So it is pi by 16. Similarly, x2 static is the middle point of this interval, pi by 8 plus pi by 4 divided by 2, and when you do this calculation, the answer is 3 pi by 16. Similarly, the third middle point is the sum of these two divided by 2, pi by 4 plus 3 pi by 8 divided by 2, and the answer is 5 pi by 16. And the fourth middle point is sum of these two divided by 2, 3 pi divided by 8 plus pi by 2 whole divided by 2, and the answer is 7 pi by 16. Now you have got the middle points, midpoints, you have everything, you have the function, you have the delta x. Now you can apply these things to the formula. So what was the formula for the midpoints estimation? The formula for the midpoint estimation was area equals to f of x1 static delta x plus f of x2 static Rn equals to this. No, it will be area, yeah, m4, sorry. For the midpoints, for the left points you can use Ln, for the rights you can use Rn. So for the midpoints, let me say Mn. So this is the Mn because we are going to calculate the things for the midpoint. F of x2 static delta x plus f of x3 static delta x plus f of x4 static delta x. That's it. We only have 4 points because n equals to 4. Now the job is Now you know everything. You know the x1 static, you know the delta x, you can put them here. So you will get mn equals to, means the value of the function at x1 static, means the value of the function at x1 static, and x1 static which I calculated here, it was pi by 16 plus yes into this delta x is pi by 8 plus the value of the function at x2 static, and x2 static is 3 pi by 16 into delta x is pi by 8 plus the value of function at x3 static, and x3 static we calculated was 5 pi by 16 into delta x plus the value of function at x4 static. X4 static is 7 pi by 16 into the value of delta x, that is pi by 8. Now again, now you have to replace this f by the original function. The function is cos, so it will become cos of pi by 16 into pi by 8, or you can take this pi by 8 common outside because every term has pi by 8. So just take it outside. Pi by 8 is coming outside, and inside you have cos of pi by 16 plus cos of 3 pi by 16 plus cos of 5 pi by 16 plus cos of 7 pi by 16. Now you have the calculator and you can find these values using the calculator and put them here, add them together, multiply them with pi by 8, and the final answer will be 1.006. This is the area, approximated area using the midpoint for this function in this interval, right?
Yes.
This whole thing is written on the pages. You can read them again, but the thing is, you will not understand if you just read the pages. Just do them on pages, do them practically, then you will understand what is happening. If you will try to just read them, then you will not understand.